Hello friends, welcome to my channel. Today's topic is 8051 microcontroller architecture. In previous video, we have compared microprocessor and microcontroller. Microprocessor is used for general application and it is used to perform computation and processing of data, whereas microcontroller is used for controlling the environment and used for specific application. So microcontroller is more powerful than the microprocessor with limited sets of instruction. If you look at the processor based system, at the center there is a processor whose function is to execute the program. But where does the program stored? So program stored in the memory. So processor fetches the instructions which are stored in the memory. So in general, there are two types of memory: a read-only memory, which is called as a ROM, and a read-write memory or random access memory, RAM. So all the instructions are stored in the ROM, which is permanently stored, and from where those instructions are fetched and executed by the microprocessor. And RAM is used for storing the runtime data. If there is if microprocessor is processing any data, is performing on any data, that data is temporarily held by the RAM, random access memory. So why these two memory are used in microprocessor system? So ROM is a non-volatile kind of memory. It means that even if power goes off, the program stored in the ROM doesn't get erased. It is permanently stored in the ROM memory, whereas RAM is the volatile memory. The program gets erased once there is a power off. So those two memories are used in any processor system. Apart from RAM and ROM, there is IO ports using which the processor is connected to the devices. So IO ports are used to connect processor to the input-output devices. For that purpose, IO ports are there. So IO ports can be configured as an input port and output port. So any processor based system consists of processor, memory, which usually consists of ROM and RAM, IO ports, and all those devices, all those elements are connected together via system bus. So usually system bus consists of address bus, data bus, which is a bidirectional data bus, and the control bus. So use of address bus is to point to any memory location which is available in the ROM and the RAM. So there is a billions of memory locations if it is a large system, and against that memory location data is stored, data or instruction is stored, which is fetched by the processor, and it is processed or executed. If it's instruction, it is executed. If it is data, it is processed by the processor. So when the instructions and data are fetched from the memory, that data is placed on the data bus, which is the bidirectional data bus. So data can be transferred in either direction, to and from the processor. And to control the operations, there is the control bus. So control bus states that whether it is a read operation or a write operation. So combinedly, address bus, data bus, and control bus is called as the system bus. So in processor based system, the main component is processor, which is a single chip and which is surrounded by many other components, as you can see here, which is memory, IO ports, which are separately interfaced with the microprocessor. So if you take the example of motherboard, there is at the center there is a processor, and that processor is connected to all the components, and that's why microprocessor based system, but nothing but your computer. So which requires a very large motherboard to accommodate all these components. And that's why the size of the motherboard is very large in processor based system. As name suggests, processor are used for processing the data. Okay, they are used in computers. So why do we use computers? So computers are generally used for the computing, processing the data. You use the computer for video editing, movie making, image editing. So it's nothing but the processing the data which is stored there in the RAM or in the memory. So this is your processor based system. So when all these components are assembled within a single chip, that single chip is called as the microcontroller. And in microcontroller there is a timer. So along with this component there is a timer. So why timer is used? Basically the timer is used to create a delay. It is used to create a delay between two events. So usually there are two ways to produce the delay, two methods, the using a hardware and a software. So you can see the hardware delay and the software delay. So hardware delay is produced by the hardware component which is physically interfaced with the microprocessor, and the software delay is nothing but the instructions or programs in iterations are used for creating a delay. So when you use the hardware delay, there is a separate component so which counts for the microprocessor. Okay, so now we are assuming in microprocessor based system those components are separately interfaced with the processor. Okay, so on the large motherboard those components are placed, but in microcontroller all these components are within the chip, are on chip components. So obviously it takes a very less space compared to the microprocessor based system, and that can be used for any appliances which is having very smaller size compared to the computer system. So timer in a hardware timer there is a separate component which counts on behalf of the processor, and when that counts complete it just gives a signal to the microprocessor. So meantime microprocessor is doing his job. Okay, so what's the use of having a timer in a microprocessor based system? Which type of timer we should have? Should we have a hardware timer or a software timer, or in what way the delay could be created, using hardware or using software? So if you compare the hardware delay and the software delay, okay, when you use the hardware delay as a separate component which is interfaced with the processor, obviously since it is the separate components it requires separate interface, it requires power supply. This is a physical component, obviously it's increasing the cost. So the incorporating timer in your processor based system again increasing the cost of the system. The advantage of software delay is that instructions are repeatedly executed to create a delay. Like in C we use the nested for loop to create a delay, but at the end if you look at the larger picture, so hardware delay, if you use the hardware delay in your system, it's doing the job of counting, okay, or producing a delay. But meantime your processor gets free, it makes your processor free. What if you are using software delay? Software delay is nothing but the instructions which are repeatedly executed. So who is executing the instructions repeatedly? Obviously microprocessor is executing the instructions repeatedly, so microprocessor is busy doing that. It cannot do any other things. But a hardware delay, the importance of hardware delay is that since a hardware delay is the separate component, microprocessor becomes free to do his own job. But in microprocessor based system, all those components are the separate individual components which are interface with the microprocessor. So in microprocessor based system, suppose if you require IO devices, there is a separate chips 8255 programmable peripheral devices which is to be interfaced with the microprocessor. If you require timer, there is a 8253 programmable interval timer PIT. That's a smart IC which has to be interfaced with the microprocessor. Likewise, it is increasing the complexity of the processor based system. But in microcontroller, all those components, ROM, RAM, timer, IO ports, are fabricated on chip, and in processor based systems which are separately interfaced with the processor, making your system larger, complex. So that's a main advantage of having microcontroller. So this is the diagram of the microcontroller. In the general diagram of the microcontroller, which consists of processor, which is a 8051 is a 8-bit microcontroller, so it's having a 8-bit processor which performs arithmetic and logical operation using 8-bit ALU. It is having ROM for storing program permanently, so size of the ROM is 4 KB. RAM, it is also having RAM of a 128 byte. Then it is having 4 ports, P0, P2, P3. So those are the 8-bit ports. So those ports are bidirectional, and these ports can be configured as the input or output port, or you can switch in between input and output configuration when you are using it. So what's the use of the ports? To connect the devices. So any input or output devices can be connected via port to the microcontroller. Then there is two timers, two 16-bit timers. We have already seen this in the features of the 8051. So it is having T0, T1 timer, which is used to create a delay and for a counting purpose. So since each timer is a 16-bit, the range of the timer goes from 40000 to FFFF. So likewise, we have 65536 number of pulses which can be counted by the timer, approximately 65,000. And apart from all this thing, there is a serial port. RXT and TXT are the pins which is used for the serial communication. Why serial communication is required? So here we have IO ports, which is the parallel communication, which offers parallel communication. So what is a serial communication? In serial communication, data is sent bit by bit, and in a parallel communication, data is sent parallelly. At a time, a chunk of data or group of data is sent. So what's your use of the serial communication? When we are having the parallel communication, which is faster than the serial communication. The serial communication is used for the longer communication, longer distance communication. And even though the IO ports, which offers parallel communication, which is more faster than the serial communication, the serial port is used for the longer distance communication. So this is the detailed diagram of the microcontroller. So in general, it is having CPU, memory, IO ports and timer, and every component is arranged in these three sections. Like a CPU is having ALU, 8-bit ALU, PSW, AB, program counter, DPTR. Memory is having spatial function register, RAM, ROM, and IO port and timer is having the ports and latches or buffer or driver, you can say, and all the control signals. So let's see each and every section in detail. So if you look at the CPU, the CPU consists of 8-bit ALU, PSW, A and B, register A and B, which is the data register. This register contains the data, whereas program counter and DPTR are the address register. These registers are used to hold the address. So using program counter and a DPTR, the 16-bit address is provided to the internal RAM and ROM, and against at every memory location there is a 8-bit of data, and that 8-bit of data is placed on the data bus and given to the A and B, and eventually it is processed by the ALU. So internal ROM is addressed using 16 bits. So address bus which is connected to the internal ROM is a 16-bit long, and 8-bit wide data bus is connected to the internal ROM to transfer the data to and from memory. Whereas internal RAM is having 8-bit address bus, since the internal RAM is of 128 bytes. So address bus is only 8 bits, and against each memory location 8-bit of data is stored. So data registers are the register A and B. So 8051 contains 34 general purpose or working registers. The two of these register A and B comprise the mathematical core of the 8051 CPU. So A and B, it gives two operands to the ALU. Usually instead of B, the registers are used. Like there are in the register bank, there are R0 to R7 registers. So along with A, in most of the cases those registers or memory are used as the second operand, but in some cases A and B are used as the operands which are given to the ALU. ALU performs the operation, which could be arithmetic and logical operations. After performing the operations, a result is stored into A, and after the result, the status of the operation is stored in the PSW. Okay, the PSW is nothing but the 8-bit flag register. So accumulator register is the most versatile of the two of CPU registers, and it is used for many operations including addition, subtraction, integer multiplication and division, and boolean bit manipulation. A register is also used for data transfer between 8051 and the external memory, whereas B register is used with A register for multiplication and division operation and has no other function other than as the location where data may be stored. So here you can see the syntax for the multiplication and multiplication operation, MULAB, and ALU is used to perform all the operations. The program status word is basically used for storing the status of the result. When any arithmetic and logical operations performed by the ALU, so according to the result, okay, some bits are altered. and each bit is having distinct meaning. So each register can be individually tested in your program, and accordingly microcontroller can take some decisions. Again, the ALU can change the content of the PSW using such instructions, using move instructions, move PSW comma immediate data. So PSW is also accessible for the programmer. Then address register is program counter and the DPTR. 8051 contains two 16-bit address register, program counter and DPTR, and each one is used to hold the address of byte in the memory. So program counter is pointing to a memory location which is to be executed. So when microcontroller is reset, program counter by default is set at 0000H. Okay. So program counter is basically used to access the ROM. The program ROM may be on chip at address 0000H to 0FFFFH, and external to the chip for address which exceeds 0FFFFH. So program counter is used to access internal ROM as well as the external ROM, which is having total address from 4 zeros to 4F. So once the instruction is fetched from the memory location given by the program counter is automatically incremented by 1, which is pointing to the next memory location. So next is DPTR. DPTR is a 16-bit pointer, data pointer. So this data pointer is used to give address of the data in internal RAM or could be external RAM. Okay, so there is every possibility that in our embedded system we have interface external RAM or external ROM with the microcontroller. So if you have a large data set, that data set could be stored in an external RAM and which is interfaced with the microcontroller. So using 16-bit, you can address up to 64 KB of internal RAM, and that data can be accessed in any manner. Okay, in sequentially, in a reverse order, in a random order. DPTR register is made up of two 8-bit registers, namely DPH and DPL. Why? Because microcontroller 8051 microcontroller is the 8-bit microcontroller and which can process 8-bit of data at a time. So suppose if you want to change the content of DPTR, it's not possible to change the content of DPTR at one time, in a one go, and that's why a DPTR register is made up of two 8-bit registers, namely DPH and DPL. Data pointer high, data pointer low, which are used to give the memory address for internal and external instructions and external data. So DPTR is at the mercy of the program instruction and can be specified, can be used bytes 16-bit name DPTR or each individual 8-bit register by their individual name like a DPH or DPL. So how the data pointer is changed, is altered when it comes to accessing data from the external memory. Suppose the DPTR is 123 and suppose if you want to increment it by 1, and the microcontroller 8051 is a 8-bit microcontroller. So instead of incrementing whole 16-bit, we can increment only a lower 8-bit. So only the content of a DPL is fetched into ALU, and then increment operations performed, and again the result is stored back in DPL. Okay, so when you use a DPTR, it requires a 16-bit operation, and when you use a DPH or DPL, it's used for 8-bit of operation. Again, as the unlike a program counter, DPTR is not an auto increment register. You need to increment it in a loop or in other manner. So other sections like a PSW, memory organization, latches, the ports of 8051. So there is a separate video on these topics. So if you like the video, do subscribe it and hit the bell button.